Hello everyone and welcome to our today's class. It is our first lesson on the topic equilibrium and center of gravity. So as usual, let me start by giving you the quote of the day. The quote of the day is interrogative in nature and it states that, why do birds live in the same place or nests, yet they have wings to fly to whichever places they wish to live to? So we'll discuss that quote at the end of the class today. So today we are looking at equilibrium and center of gravity. So the word equilibrium simply is derived from the word equal. So when we say two or more things are at equilibrium, we mean they are in a state of balance or they are equal to each other. For example, in our previous topic, we did say that we did state the principle of moments, which said that at equilibrium, the sum of clockwise moments is equals to the sum of anti-clockwise moments. So when we talk of equilibrium, we simply mean a state of balance. Then center of gravity, this one is whereby the whole weight of a body simply acts from. So let's start by defining what we mean by the word center of gravity, what we denote by COG. So whenever you see COG in physics, it simply denotes the center of gravity. So what is the center of gravity? So center of gravity of a body refers to the point of application of the resultant force due to the Earth's attraction on the body. So we are saying that center of gravity is defined as the point of application of the resultant force due to the Earth's attraction on the body. Alternatively, you can define the center of gravity as simply the point where the whole weight of a body seems to be concentrated. A point where the whole weight of a body seems to be concentrated. So it is important to note that a body will always balance at its center of gravity, because that is where the whole weight of a body actually seems to be concentrated. So there are various ways of determining the position of center of gravity for objects. So we look at determination of center of gravity of objects. Now we have two main categories of objects. One, we have what we call regular objects, and also we have what we call irregular objects. So regular objects, these are objects that have regular shapes. For example, a triangle, for example, a square, a rectangle. That is all objects that have a definite or a regular shape. Whereas irregular objects, these are objects that have irregular shapes or indefinite shapes. So how do we define, how do we find the center of gravity for regular objects? That is objects that have a definite shape. So the first object you are looking at is what we call a uniform rod. So to determine the position of center of gravity for a uniform rod, first of all you just balance, you balance the rod. So you balance the rod, then the center of gravity is at the center of the rod. So the geometric center of the rod, that is where we'll have the position of center of gravity. So to determine position of center of gravity for a uniform rod, you simply suspend it in air, or you simply balance it. You balance it, then the center of gravity will simply be at the center of the rod. So like in this case, this is where we will have the position of center of gravity, that is at the center of the rod, that is after actually balancing it. Then for the case of a meter rule, remember a meter rule, we did say that it runs from the 0 centimeter mark up to the 100 centimeter mark, because it is 1 meter. The total length is actually 1 meter. So for a meter rule, you also balance it, then the center of gravity will be at the 50 centimeter mark. Why? Because the meter rule is actually 100 centimeters. So the center, that is 100 centimeters divided by 2, you actually get 50 centimeters. So the position of center of gravity for a meter rule will always be at the 50 centimeter mark, that is after balancing it. Then next we look at the position of center of gravity for a square plate. So to determine the position of center of gravity for a square plate, the procedure involved is that, one, you construct the diagonals. You construct the two diagonals of the square. So this is our first diagonal, then this is our second diagonal. Then after constructing the two diagonals, then the point of intersection of the two diagonals would be the position of center of gravity. So for a square plate, you just construct the two diagonals, then their point of intersection, that is where the two diagonals meet or intersect, would represent the position of center of gravity for that square plate. Then next we look at a rectangular plate. So how do we determine the position of center of gravity for a rectangular plate? The procedure is similar to that of a square plate. So to determine position of center of gravity for a rectangular plate, the procedure involved is that one, you construct the two diagonals, then the point of intersection of the two diagonals will be the position of center of gravity of the rectangular plate. So you simply construct the first diagonal, then you also construct the second diagonal of the rectangular plate, then the point of intersection of the two diagonals will represent the position of center of gravity. And to determine the position of center of gravity for a triangular plate, remember a triangular plate means that it is in the shape of a triangle. So to determine position of COG for a triangular plate, what you do, you just construct the perpendicular bisectors of the sides. So you bisect this side, the first side, you bisect it, this is the bisecting line. Then you also bisect this other side, then you also bisect the upper side. So the procedure is that you construct the perpendicular bisectors of the sides, then the point of intersection of those bisector lines is the position of center of gravity. So for a triangular plate, you simply bisect, you construct the perpendicular bisectors of the three sides of the triangular plate, then the position of the point of intersection of the three lines of intersection represent the position of center of gravity. Remember, you can alternatively just use two lines. You just bisect two of the sides, then the point of intersection will be the position of center of gravity. But the third line of intersection is just to confirm the accuracy of the first two lines or perpendicular bisectors of the sides. Then for a circular plate, you simply construct the diameters. You simply construct any of the two diameters. Then the point of intersection of the two diameters or any other or even three diameters will represent the position of center of gravity. So remember, the point of intersection of the diameters also represents the center of that particular circular plate. So you simply construct any of the two or even three diameters, then their point of intersection will represent the position of center of gravity. Then for the case of maybe a cubic block, you just construct the diagonals, then the point of intersection of the diagonals will represent the center of gravity. Now for a cylindrical shape or for a cylinder, to determine its position of center of gravity, the procedure involved is that you construct the vertical and the horizontal axis, then the point of intersection or the midpoint of those axes gives the position of center of gravity. So you construct the vertical axis, this is our vertical axis, then you also construct the horizontal axis, then the point of intersection of the two axes will actually represent the position of center of gravity for a cylindrical shape. Then for a spherical shape, you just construct the diameters of the sphere. So for a spherical shape, you simply construct the two diameters. So I have my first diameter here, then the second diameter here. So for a spherical shape is similar to a circular plate. You just construct the diameters of the spheres, then the point of intersection, which is the center of the sphere, is simply the center of gravity of that particular spherical shape. Then we have another shape here which we are calling actually a cone. So to determine the position of center of gravity for a cone, the procedure involved is that one, you construct the perpendicular bisectors from the base. So from the base here, you construct a perpendicular bisector of this cone. Then from this other base also, you also construct a perpendicular bisector. So you construct the perpendicular bisectors from the base. Then the point of intersection, which is a third of the axis, a third of the axis from the base actually gives the center of gravity. Alternatively, you can just construct an axis here, that is the vertical axis, then you measure a third from the base, that is 3/4 of this line will represent the position of center of gravity. Or alternatively, you just construct the two perpendicular bisectors from the base, then their point of intersection, which is actually a third of the axis from the base, gives or represents the position of center of gravity. So in this case, this is our position of COG or the center of gravity. Then for the case of a ring, you just construct the diameters. For a ring, you construct any of the two diameters. Then the point of intersection, which is the center of the ring, represents the center of gravity for that particular ring. Then for an L-shaped diagram like this one here, to determine the position of center of gravity, the first step, you divide the L-shaped into two rectangles and construct the diagonals of each rectangle. So like for my case, I've divided it into two rectangles. This is my first rectangle, then this is my second rectangle. So after dividing it into two rectangles, you simply construct the diagonals on each of the rectangles. So for my first rectangle here, this is my first diagonal, then this is my second diagonal. For the second rectangle here, this is my first diagonal, then this is my second diagonal. So first of all, you divide the L-shaped into two rectangles, then you construct the diagonals on each of the rectangles. Then after that, you join the point of intersection. After that, you join the point of intersection, then bisect the line. So after constructing the diagonals of the two rectangles, you look at the point of intersection. So like for my first triangle, this its point of intersection of the diagonals. Then for my second rectangle, this is the point of intersection of the diagonals. So you actually join the points of intersection. So like for this case of mine, this is my line which is joining the points of intersection. Then after joining the two points of intersection, you construct a perpendicular bisector of this line which is joining the points of intersection. So this is actually my perpendicular bisector, that is of the line joining the points of intersection. So we've said you divide the L-shaped into two rectangles and then construct the diagonals on each of the rectangles. After that, you join the points of intersection, then bisect the line. You bisect the line actually joining the points of intersection. So this is my perpendicular bisector of my line joining the points of intersection. Then the point where the bisector meets the line is the position of center of gravity. So the point where this bisector of mine is actually meeting the line joining the two points of intersection of the diagonal. So this point is my position of center of gravity. So actually the procedure is very long. The first thing, you divide the L-shaped into two rectangles, then you construct the diagonals of the two rectangles, then the point of intersection of the two actually rectangles you join the point of intersections. Then after that, you construct a perpendicular bisector of this line that is joining the points of intersection. Then the point of intersection between your perpendicular bisector and the line joining the two points of intersection of the diagonals is actually your position of center of gravity. Then lastly, we look at the square with center cutoff. So how do we determine the position of center of gravity for a square with center cutoff? So for this case, you just construct the diagonals. Then the point of intersection of the diagonals actually represents the position of center of gravity, that is as shown here. So the position of center of gravity for regularly shaped objects. So next, we look at how to find the position of center of gravity for irregularly shaped laminar objects, or simply irregularly shaped objects. So the procedure involved in this case, first of all, before we look at the procedure, you need to know the apparatus required. You will need a stand, you will need a thread, you will also need the irregularly shaped objects. Like for my case, I'm using a cardboard. Then you will also need what we call a plumb line. So the procedure involved, first of all, you make three holes, that is hole A, this is my hole A, then hole B, then hole C. So you make three holes, that is A, B and C, on the edges of the irregular objects. So this is my irregular objects. So you make three holes, hole A, then hole B, then hole C, along the edges of the irregularly shaped objects or of your cardboard, like for this case of mine here. Then after that, you suspend the irregularly shaped objects, you suspend it by a rod through hole A. After that, after making the three holes, you suspend the irregularly shaped objects through one of the holes. For example, I'm suspending it through hole A. To suspend is just to you place a rod through hole A, then you allow it to hang freely. So you suspend the irregular shaped objects through hole A. Then after that, you tie a plumb line. This is my plumb line. After that, you tie a plumb line on the rod besides the irregularly shaped object. Then after tying a plumb line on the rod besides the irregularly shaped object, after that, the irregularly shaped object and the plumb line have actually stopped swinging. So remember, when you attach a plumb line, the irregularly shaped object was actually swinging. So you allow it to swing until actually the swinging stops. That is, you allow it to settle. Then after the irregularly shaped object and the plumb line have stopped swinging, you draw a vertical line on the irregular object as set by the plumb line. So you draw a vertical line that is along the direction of the plumb line. So after the regular shaped object and the plumb line have actually stopped swinging, you draw the vertical line on the irregular object as set by the plumb line. So like for my case, the vertical line through hole A will be this one, the vertical line through hole B will be this one, then the vertical line through hole C will actually be this one. Then after that, you repeat the experiment, of course, using the other holes, that is hole B and C. Then the lines of intersection of the points, actually that is what will represent the position of center of gravity. So you suspend the regular shaped object through hole A, then you allow the plumb line actually to settle. You trace using a pencil the path of the plumb line. Then you suspend the regular shaped object through hole B, then you also sketch the line of the plumb line. Then you suspend the regular shaped object now through hole C, then you also trace the shape of the line of the regularly of the plumb line. Then after that, you note the point of intersection of the three lines. So you repeat the experiment using the other holes, that is hole B and hole C. Then the lines of intersection at a point, the line of intersection, that is where the three lines intersect, would represent the position of center of gravity. Then after that, you balance the irregularly shaped object with the tip of the pencil at the point of intersection of the three lines. Then after balancing, actually the point of intersection of the three lines represents the position of center of gravity. Now a person will ask himself, if we just use hole A and hole B, will still determine the position of center of gravity or the point of intersection. Why do we have to use the third hole? Or in short, what is the purpose or the function of the third hole? The function of the third hole is just to confirm or to check the accuracy of the first two holes. So if you realize that the plumb line of the third hole is also going through the same point of intersection, then actually that confirms the accuracy of the first two holes. It confirms that actually the measurements made using the first two holes were accurate. So the purpose of the third hole is simply to check or to confirm the accuracy of the first two holes. Then if a body is actually hollow, or if it has legs, like for the case of a tripod stand, then the position of center of gravity is likely, or it may be in the space outside the material of the body. So we've come to the end of our class today, but we cannot end our class without discussing the quote of the day. So the quote of the day, it was actually an interrogative question which stated that, why do birds live in the same place or in the same nest, yet they have wings for flying to whichever place they wish to live in? So what does this particular question or this particular quote mean? So I have a suggestive answer to that question. That is, the question is, why do birds prefer to live in the same place or nest, yet they have wings for flying to whichever place they wish to live? So I have my answer here. So I guess it is because they fear trying out new things, or because they are afraid of what could go wrong. So the bird in this case actually in this context represents us, that is we human beings. So the nest that is where the birds actually live represents the excuses and our complaints and also our past. Then the wings of the birds in this case represents our abilities and our full potential. So if we want to get the right answers, we must ask the right questions. And my questions are: 1. How many times have we stopped trying out something new just because we fear what could go wrong? I guess many times. Then my second question is: how many times have we allowed situations that happened in our lives long time ago be our excuses for not trying out something new today? Again, I guess the answer is many times. So what we need to do, unlike the birds, remember the birds have wings, meaning they have the ability to fly to whichever places they want to live, but they still prefer to live in the same place. The reason is because maybe they fear the new places. Actually, they could not easily adapt with the new conditions. Yeah, so that represents how we actually fear taking another step in our lives, just because we fear of what could go wrong. Yeah, we don't actually think of what could go right. Our minds are actually conditioned to only see the negative sides, that is to think of what could go wrong. So what we need to do is that you need to drop all the complaints and excuses, which represents our nest or our comfort place of living, and start unleashing our potential, our full potential. So our full potential for the case of the birds represents the wings of the birds. So if we don't learn how to program our minds today to think positively, then our minds will by default be programmed by the kind of people we interact with and the kind of content we feed our minds, that is from social media. So it is a high time we start filtering what we allow to enter our minds, because it's insane to continue feeding your mind with negativity or negative content and expect it to think positively. That is an insanity of the highest order. And lastly, instead of worrying for what could go wrong, if you took a step forward towards achieving your greatness, you have to start thinking or getting excited of what could go right if you took the same steps towards achieving your greatness. So don't worry for what could go wrong. Instead, start getting excited for what could go right. So this is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.